In this video, we'll be talking about computer vision with machine learning. In the previous video, we started looking at computer vision, but in fact, it's a lot harder than all of the techniques that we showed in the last video. The bottom line is the real world is just not as simple as color blobs or simple shapes and so on. So the things that we're typically interested in for robotics or any autonomous systems can be classified as two types of problems for vision. One is recognition. So what is this image? For example, this could tell you whether you're looking at a scene of a beach or a mountain or cats or dogs and so on. On the other hand, there is detection, and that is a bit more specific. It's not just something about the image in itself, but you're looking for specific things in the image. So for instance, you might be looking for persons, for a self-driving car, for a service robot. You not only need to know whether there's a person in the image, but the exact location of the person is also important. And really for both of these techniques, machine learning has been proven to be very, very good at these tasks. Now, machine learning for computer vision takes a couple of approaches. There's the more traditional approach, which uses something that's been used for a lot of other tasks in computer vision, which is feature extraction. Features are these hand-engineered things like edges, corners, gradients, that you can use to detect some fairly complicated things like faces, you see on the left side, or handwritten numbers so that you can classify them. Both of these basically take this combination of doing some kind of manual extraction of features and then putting them through some kind of machine learning model like a classifier to figure out what these features can map to. For example, for the handwritten number case, what type of features make it different to be a 2 versus a 3. Now, more recently, there's been what's known as end-to-end learning, which is usually done through deep learning or the use of neural networks, which means that you don't have to write any features by hand anymore. It's really just throwing an entire neural network model at the problem. So you go directly from labeled data to some kind of classification or object detection output. And that's why this is all often known as end-to-end learning. And I've mentioned data a few times. I think it's very important. No matter which machine learning technique you're using, it's very, very important that you're going to have to train these models with labeled data. The first approach at the top usually will require less labeled data at the cost of you having to figure out the features. And then deep learning will often require lots and lots of data. People have made businesses out of just collecting data. So we've talked a little bit about models. Now, the next question is, how do we choose one of these models? There's a couple of options, right? First of all, there are a lot of pre-trained models that already exist for performing lots of different tasks. MATLAB also contains packages for pre-trained models, and we will see that throughout this video. You can also take models that other people have trained in other frameworks like TensorFlow Keras, Caffe, or the Open Neural Network Exchange, ONNX, so that you can bring them into MATLAB for further analysis or processing. Now, on the completely other side, you have training a model from scratch. So whether it's a neural network or not, you can figure out some kind of model architecture or feature type of sets that you want to use, and then use MATLAB or other tools to train one of these models on your own data or some data that you might have found online. There is also an intermediate step, which is called transfer learning. And this is if you start with a model that's already been trained for lots of hours on a completely different set of data, and then with making some minor adjustments to your model, you can then retrain it on your own data while still retaining a lot of the features that the pre-trained model has learned. So through this video, we'll see a couple examples of a few of these approaches. So we'll start with a first example where we're going to use a pre-trained model using feature extraction for face detection. So we're going to go to the vision folder and then expand the person detection folder under here. And then I'll go to vision person detection. As you see here, just as part of the script, you can choose whether you want to use ROS or your webcam in case you just want to quickly test with your webcam. But I'll stick to ROS for now because I have the robot in front of me. The more important thing is figuring out the detector that we want to use. So here there's going to be 3 pre-trained detectors that are part of the computer vision toolbox that you can choose from. There's a face detector, which uses the vision cascade object detector. And then there are a couple of detectors also for upright people. And then the rest is just going to be stepping through these detectors. Now, if I run this with the face detector, as you can see, here I have my video player, and it's not detecting my face until I turn more to face in front of it. And that's because this detector has been trained such that it's on frontal faces. So there you can see it's mostly detecting my face if I'm looking straight at the robot, and sometimes you get some false values. Let me change the detector to another one, which is person ACF, or this is using the people detector ACF pre-trained model for that uses the aggregate channel features detector. And you see that when I stand here, the object detector is going a little bit crazy. And that's because, again, this is trained on upright people. So by me standing right in front or sitting right in front of here, it's not going to do anything. But if I stand up off of my desk and I move off to the side, then here you see correctly it's detecting me standing in front. And sometimes it's getting my reflection over here on the window as well. So that's one approach. Now, I do want to go back to the face situation. We were able to correctly detect faces, but we weren't able to really say much about what the face was. For example, what is the gender of the person, or the age, or the emotion. So that's where we can do a couple of other things. Once we're able to detect a face, we can crop out that part of the image and then put that through another machine learning classifier. And that's kind of what I've done with some of these other scripts. So let's dig into the gender net for a bit. So I'll open up this import gender net live script. And what you see here is that now I'm using the ability to import cafe models. So I found a cafe model online, and I could import some classifiers for gender and for age. So I'm really just importing this classifier here and then using it as part of another script. So if you go to Vision Gender Detection, you see that this will start off pretty much the same as the previous script that we showed, where we're connecting to the robot to receive our images, using a cascade object detector to detect faces. But then the next part, as we're looping through the image, is we're going to be predicting the scores or classifying using that neural network for each of the faces that were detected. So let me run through this script and you'll see how that is a little bit different. Because now it's not only my face that's being detected, but I get a score for which gender it thinks I am. So as you see here, I'm labeled with M, and it's about 99% accurate or certain that my gender is male. So you can try this with your own faces. You can certainly stand in a group and then see whether it classifies people correctly. Just as a side note, and this is not included in the file materials, but here's another different type of detection, which is using deep learning completely to do both face detection and classification of the faces that were detected. So as you see here, again, you have a deep learning model that's completely figuring out the bounding box in my face, my gender, it's guessing my age, and it's trying to guess at my emotion. So let's see if I can maybe look angry or try to look happy. Sometimes it works out. This is, like I said, a completely deep learning solution. And it's using a popular object detector called YOLO, or You Only Look Once, which is also possible to train or import using MATLAB. You'll see models like this, YOLO or MaskRCNN, as very popular techniques for object detection with vision. So now let's go back to our challenge files. And I also want to talk a little bit about object recognition. If you expand the object recognition folder, you'll see a couple of scripts here, and the one that I'll be using is Vision AlexNet. Before that, I want to talk a little bit about those pre-trained networks. So in MATLAB, if I go to my add-ons section up here on the tool strip, then you will see in the add-on explorer that I can actually search, for example, for this AlexNet, which is one of the pre-trained neural networks that you can download as support packages. There are more. So for example, if I look up Deep Learning Toolbox Model, then you'll see that there's quite a few other pre-trained networks that you can download separately. And the reason you download these separately is because they take up a lot of disk space. So you really just want to get the ones that you maybe care about trying. Again, in this case, I'm using the AlexNet pre-trained network, which is a famous one from a couple years back. And this only does object classification. So it will look at the whole image and try to tell you what's in it. If I just scroll down past the raw setup, again, I'm just loading AlexNet with a script that I made. So I'll show you that. Where here I'm just loading the pre-trained AlexNet model because AlexNet has 1,000 different classes. I'm just filtering it down in different categories so that I'm only grabbing the classes that I care about, and that way you don't get all sorts of wild guesses for very specific classes. So for example, I've got different categories like bananas and slugs, oranges and ping pong balls, different types of sports balls, and so on. And by doing that, and then of course making some predictions, I can test out my image classification. First, I will connect to the robot, and then I will run through the script. when the video player comes up, you see that I'm being classified as a water bottle. And that's an issue with classification where even if there's no object of interest, it will still have to guess something. And that's not necessarily good. So you wanna really make sure you have an object in front of you if you're doing just classification. Now, if I start bringing objects that AlexNet has been trained on, for example, I can bring in this banana, and sometimes it can guess it correctly if I orient it in just the right way, which is just fine. Or if I bring my cup of coffee, then you see sometimes it can detect that as a coffee mug. Sometimes it gets it wrong, and it really depends on where I put it, how far in the image. So it can be a little fickle if you don't train it on a lot of data. And there's things that it just doesn't know about, like this rubber ducky. It really doesn't know what this is. But you see that once I get out of the water bottle realm, it thinks maybe it's a ping pong ball or a football helmet. I don't know. On the note of football helmet, another wrong classification that I found was if I get my headphones, you see that they are sometimes classified as a football helmet, which, it kind of looks like a helmet, but it's not. And that's because we did not train this network to know what headphones are. So when you're doing classification, make sure you train this with the specific things you want, and watch out because classification is not the same thing as object detection. So it will look at the entire image, even if your object is very far in the background or takes up most of the foreground. So that's what I wanted to say as an introduction to machine learning for computer vision. Of course, there's a lot more to these techniques, and we've just scratched the surface. So I would recommend you get started by taking a look at our deep learning on-ramp or reaching out to us if you have any questions.